It's one thing that has really taken even the environmental health field a long time to truly appreciate is the degree to which underlying genetics translates into different health outcomes. Why does one person get sick but not another person? Then a very wide open and unanswered question within the field. And as it turns out, genetics might underlie a lot of that. My name is Cavin Ward-Caviness. I'm a computational biologist in the Environmental Public Health Division at the US EPA. So the Title 42 program, I think, was really essential for me being able to come and join the Environmental Protection Agency. I have a very unique set of skills in that I come from a computational biology program, so I'm very familiar with omics and genomics and all this big data analyses. The EPA was looking for somebody who could do both their sort of traditional epidemiology, trying to understand who are the most sensitive individuals, but also this newer molecular epidemiology fields, really trying to dissect at the most fine-grained levels, how does a particular exposure translate into a particular disease. I seem to be the perfect candidate at that point. What I do is try to answer two of the main unanswered questions within environmental public health. The first one is, who are the most sensitive individuals to air pollution exposures? And the second question is, what are the molecular mechanisms, the underlying biology that really connects environmental exposures to public health? We know that exposure is bad for your health. We know that it contributes to heart disease. We've seen this in animal studies. We've seen this in human studies. However, it doesn't happen for everybody, and it doesn't happen for everybody at the same time or at the same rate. The particular genetic mutations that one person has as compared to another person might make them more or less protected for one particular exposure or another. And we need to understand at a much deeper level who it is that's most sensitive to air pollution, so we can target them with communications, with intervention strategies. And that's communication that I think the states want to do, that's communication that the regions want to do, and that really the local communities want to be able to give out to individuals, particularly the most vulnerable individuals. Do we put a school right next to the highway, or do we move it a few miles down the road? Or do we put a hospital right next to this busy intersection, or do we move it a little bit further away, possibly because we know that the people in here might be more sensitive to these different exposures? And to answer these questions, what I do is I take large amounts of data. This is often called big data in the field. So whether it be large amounts of electronic health records on the various diseases people have, and also how long it took them to develop the disease. A lot of my work is really just to prioritize, here's what should be done next. And this is not just for stakeholders and agencies, but also for the research community in general. If we can start to do these studies, and in particular, if we can start to communicate these to the states, and we can start to communicate these to local stakeholders like hospitals, physicians, healthcare companies, then we can start to really make strong strides in reducing our public health burden from these chronic diseases.